Let us discuss the 2-bit flash type ADC. I hope you know the basics of potential division or voltage division though. So I have 4 10 ohm resistor, all are connected in series. If I connect this configuration with 12 volt DC supply, then the voltage drop across each resistor will be 3 volt, 3 volt, 3 volt. So the voltage is equally divided. When you add all the 3, you will get again 12 volt. So with respect to ground, voltage across the first resistor is 3 volt. I hope you know the concept. So now take a comparator, first comparator, the negative terminal of the comparator is connected across this connected this point, and take one more comparator, again the negative terminal is connected to second resistor, the third comparator's negative terminal is connected to the inverting terminal is connected to third resistor, and in the positive side, so here you must know one thing. So across the first resistor the voltage drop is 3 volt. Across the second resistor, if you measure the potential, it will become 6 volt. Then voltage drop across third resistor will become 9 volt. So 3 volt, 6 volt and 9 volt. I hope you know the concept very well, right? I would like to show that again. Across the first resistor the voltage is 3 volt. Across the second resistor the voltage is 6 volt. Across the third resistor the voltage is 9 volt. So here the first comparator is connected in the first resistor, the second comparator is connected in the second resistor, the third comparator is connected in the across the third resistor. So here the potential is 3 volt, here it is 6 volt and here it is 9 volt. Then what about this positive terminal or non-inverting terminal? These positive terminals are joined together. There is no connection between positive terminal and negative terminal. That's why I have shown this loop. A loop means jumper. So there is no connection between this wire, blue color wire and red color wire. And I hope you know the setup very well. It is a boiler and temperature sensor. Generally it is a RTD. The output of the RTD will be analog value. This RTD is connected to this positive terminal of all the comparator. So this is your input analog value. This analog value has to be converted into equivalent digital value. And this output of the comparator is given to priority encoder. And the priority encoder, it takes 4 input and it converts it into 2 output, that is Y0 and Y1. So let us discuss the operation of 2-bit flash type ADC. This one is enable. The same setup. Suppose if the boiler temperature is 0 degree Celsius, then your RTD will produce 0 volt, right? This 0 volt is given to this plus terminal because this red line is connected to positive terminal of your comparator. So here it will become 0 volt. Now compare the voltage. Your positive terminal voltage is 0 volt, negative terminal voltage is 9 volt. So 0 less than 9, right? So the output will be 0 because positive terminal voltage is lesser than the negative terminal voltage, so it will produce 0. And here it is 0 volt, so 0 less than 6, right? 0 less than 6, so it will become 0. So it is V1 potential, 6 is V2 potential. V1 less than V2 means it will become 0. And here it is 0, so 0 less than 3, so it will produce 0 0. So 0 0 0 1 means the output will be 0 0. Suppose if the temperature is 50 degrees Celsius means it will produce 5 volt. This 5 volt is given to this positive terminal. So 5 and 9, compare the two voltage. So again 5 less than 9, it will produce 0. So here 5 less than 6, again it will become 0. So here 5, but here 5 greater than 3. So the comparator output will be 1. So for this combination 0 0 1 1 1, the output will be 0 1. Similarly, for if it is 70 degrees Celsius, it will produce 7 volt. RTD will produce 7 volt. Now compare the voltage 7 and 9. 7 less than 9, again 0. So here 7 greater than 6, so 1. 7 greater than 3, it will produce 1. So similarly 1 0. If it is 100 degrees Celsius, it will produce 10 volt. So 10 greater than 9, so it is 1. So here it is 10 greater than 6, so 1. 10 greater than 3, 1. So for 1 1 1 combination we will produce 1 1 1. Thank you.